Hello everyone, myself Prashant Kumar. So here I will explain my topic, which is AC to high voltage DC using voltage multiplier circuit. So here we start with the introduction. So AC to DC conversion is very important because there are a lot of real life applications based on this. And the circuit which converts AC to high or desirable DC voltage is known as AC to DC converters. The process of conversion of AC current to DC current is known as rectification, in which rectifiers converts AC supply into DC supply, and transformers are used for the high voltage AC generation, which has to be rectified to DC. Here we are producing high voltage DC with the help of basic components like capacitors and diodes, in which diodes converts AC to DC and capacitors ultimately increase that voltage. Such system is called voltage multiplier system or voltage multiplier circuit. So our project aims to develop a system that develops high voltage AC up to 50 volt using a 230 volt AC input. Circuit uses capacitors along with diodes in a ladder based network as a voltage multiplier mechanism. We will see components used in circuits. So first, alternating current. As we know, alternating current changes its direction periodically and it has non-zero frequency. It is produced by AC generator, dynamo, etc. Also we can see from the graph that current changes its direction after regular intervals of time and its magnitude continuously. Then direct current that does not change its magnitude and polarity, and it has zero frequency. It is produced by cell, battery and DC generator or by rectification, etc. As we see from the graph that current has a constant value at every instant of time. Then capacitor. Basic capacitor has two parallel plates separated by an insulating material. A capacitor is used to store an electrical charge between that plates and its unit is farads. It will charge till maximum voltage drop is attained across it. Then diode. Diode is the simplest and non-linear semiconductor device used in power supplies and voltage limiting circuits. PN junction diode. Junction. PN junction is an interface or boundary present between the p-type and n-type inside a semiconductor. P side has an axis of holes and an N side has an axis of electrons, and they together constitute PN junction diode. PN junction diode has two conditions, forward bias and reverse bias. So in forward biased condition, the positive terminal of the battery is connected to the P type and negative terminal is connected to the N type as shown in the figure. So the applied potential establishes an electric field which acts against the field due to the potential barrier. So resultant field gets weakened and the barrier height is reduced. Junction resistance becomes almost zero and we can assume the part to be short circuited. And in reverse bias condition, the negative terminal of the battery is connected to the P type and positive terminal to the N type as shown. Here, applied reverse voltage establishes an electric field which acts in the same direction as the field due to the potential barrier. So resultant field gets strengthened and barrier height is increased. A high resistance path is established and therefore no current flows. Now we will see AC to DC conversion, which is also called rectification. Here we use half wave rectifier. In positive half wave, diode is under forward bias condition, so it allow current to flow through the load. But in negative half wave, diode is under the reverse bias condition, so no current will flow through the load. And then resulting signal seen across the load resistor is pulsating DC, which can be made more constant by adding capacitor to the circuit. Now circuit connection pattern. It is clear that a voltage multiplier is simply a combination of diodes and capacitors which are connected alternatively, making a ladder network like here. Diode will control the flow of current and charge corresponding capacitors. Transformer will control the power input AC. Input AC is converted to DC by diodes and gets ultimately increased by capacitors. Ideally, it takes n number of half voltage cycles to get n times higher DC voltage, but practically it takes comparatively more cycles to get the same value. In this way, voltage multiplier gives a DC voltage of high value, and the resultant voltage is equals to number of capacitors multiplied by peak value of AC voltage. The load connected is also higher in impedance to avoid large current flow.